Good afternoon. So I'm Matthew Henderson. I'm a program manager on the App Service and Azure Functions team. I specialize in features around identity and secure resource access, which is what we're going to talk about today. So let's start by just kind of giving a brief overview. Identity is all about making sure that you can control who has access to what, right? This is how you do fine-grained permissions control. This is how you make sure that you know who's accessing what secrets and from where. And this is also how you just actually manage users. How do you know who's actually able to talk to the endpoints that your application is exposing? So the way we'll do this is that we'll actually go through and build a quick scenario out. We'll actually start using a user identity. We'll restrict access to an application we're building. And then we're going to actually change the way we handle secrets in our application by leveraging an identity of the app itself. Along the way, we'll talk about some of the main issues that people run into and how they can, how you can get around those in terms of main stumbling blocks and troubleshooting and that sort of thing. I've got a few slides to go through, but then we'll very quickly get straight into demos. Does that sound good? Cool. So this isn't an overview of OAuth or anything like that, but there's two basic concepts that we have to keep in mind. One is that there's a client. That client is saying that they are someone. They are providing an identity, right? So it's one thing for me to walk up and say, "Hi, I'm Matthew," right? I'm the client in that thing. The resource is what the client is trying to get to, right? And the resource actually has to trust. Do you actually believe that I'm Matthew? Did I just lie on all those slides earlier? No, but the point being that you have two levels of configuration, right? There's one part where you're actually obtaining the identity, presenting it to the resource, and then where you're checking it and deciding what rules you're enforcing, right? My application can actually fall into both of those roles. One, I can actually be a client. I can say, hey, my application needs to go and talk to some resource. More commonly, you might see, I have users that need to access my application, right? I need to know who they are and be able to work with their data, make sure that that's flowed through the entire application lifecycle. So we'll start by just kind of going with that actual scenario. And a lot of these things that I'll be walking through apply both to App Service and Azure Functions. So we'll start with Azure Active Directory. That's actually a pretty good model for doing both directions. And of course, we work really well with it in the cloud. One of the nice things about, of course, Azure Active Directory is it works with on-premises Active Directory, so we get that nice hybrid mode. But importantly, we can make it so that our application can very easily log users in, see which identity they are, leverage that, of course. And then we can also integrate with all sorts of other great APIs. We saw lots of things about the Microsoft Graph this morning, all sorts of great things coming out that are all AAD backed. So I promised I would get into demos quickly. Let's go. So, see that? OK, so I'm in the Azure portal, and I'm actually working against a Linux application. This is something we're announcing at Build. So our authentication and authorization pieces of App Service are now available for App Service on Linux and Web App for containers. This is in a preview capacity. If I go into the portal, I see an authentication and authorization section. Actually, let me just show you what this app is. I've actually just deployed the default template. So this is just a simple app that should respond. There we go. So we've got an app up and running. And then we'll go in, and in authentication and authorization, we'll turn it on. And there's two pieces of config we have to provide here, right? One is, how do I actually make sure the user's logged in? And then how do I make sure that only logged in users can get to my app? So this first drop down here, we're actually going to say that the user has to be logged into with Active Directory. If they try and get to our site and they're not, we're going to reject them. And then we'll go into Active Directory configuration, and we're going to hit this express thing. This is one of the fastest ways to get your app up and running with AAD. You can provide advanced configuration if you want to go and manually get the client ID, secret, and all those properties. But with Express, we just have a few clicks. So we'll go ahead and hit OK. And then don't forget to hit save. I see this all the time. Don't forget to hit save. And what will happen is we'll go into Active Directory, create the app registration, provide all the secrets, and my app will be good to go. So then, if I go ahead and grab the URL for my site, we're having some portal issues today, folks. All right, there we are. We'll go ahead and open it in private session so I don't get any SSO. And I'm just going to log into my site. So actually, I'm really just going to navigate to the site itself, right? Remember, we've protected it. And what we're going to see is that it's going to immediately redirect me to the AAD login screen. OK? So all of a sudden, nobody can get to that site unless I know who they are. Now, you may not want to actually have it so that they're actually always redirecting, or you might have an explicit login button in your app. There is actually a mechanism for that. So there's a set of endpoints that we provide once you've enabled app service authentication authorization. So if I go to /auth/login/AAD, I don't know if folks can see that okay. We'll just zoom in on that. So if I go to this endpoint, that'll actually trigger the exact same login flow. And in this case, we're using the normal browser session. So what should happen is it'll automatically log me in and present me with a consent prompt, right? So after I've logged in with AAD, it says, hey, this application wants this information. In this case, just basic profile. If I did want to go ahead and provide additional things, first off, note that we have this explicit login done thing. So what's happening here is when you're using that direct API, we're basically assuming that you're trying to do an API style flow. So we're going to give you a token. In the example I showed earlier where we just automatically redirected, I actually had a session cookie, and that's what actually allows me to continue working with the site going on. In this case, I would use the token. If I wanted to change what those permissions are in that consent prompt, we actually have full access to the AAD registration, right? So remember, we just did everything behind the scenes, but if you want, you can go see everything about AAD. We can go into Manage Application here, and we get the full experience that you would normally have as an admin. We can also go directly into the permission set, and that's where you go ahead and define things. So if you wanted to add permissions to the Microsoft graph, you'd do it here. If you change the permissions, you must relog in your users because the tokens that they have will not be valid. That means that you have to get them to go through that login flow. And as we were talking about, you saw that I just kind of got navigated right away, right? So the trick to that is we actually flow any, we flow any parameters that you provide on the request back to AAD. So there's actually a flag in AAD for explicitly showing the consent prompt. And to do that, I just set a query string parameter, and that's prompt equals consent. Right? So if I run that, we'll get navigated back in through that login flow. It's going to ask me to sign in, picking an account that's already, I didn't have to enter my password again. But again, here's the consent prompt. This is where any changes we made would show up. So the next thing we want to talk about is what do we actually do with that identity, right? So we've successfully logged in, we've secured, we've even gotten permissions to do all sorts of fun things. First, there's an endpoint, again, under the /auth prefix, but in this case, it's /auth/me. And if I go to that endpoint, I have to have a token or a cookie or something, right? So that's how we were able to get this information. But this is basically just a set of profile information that AAD gave us at initial login time, in addition to some tokens and things like that. So we've got all sorts of basic profile information. If I wanted to do more, I would actually need to leverage some tokens. And in fact, we're going to go ahead and just grab this token just for later. So this is the ID token from AAD. So you do not have to call this endpoint in order to get all of the profile information, right? That's not something you'd actually want to do. You're doing an HTTP call every time a user's doing an action. That's not really performant. So we actually flow a lot of that information in as headers on the request. So those will all be prefixed with XMS client or XMS token, as we've got in the comments here. And the idea is that I can grab the ID token, and then I can actually go ahead and call AAD. This is using the Active Directory authentication library, actually. And I need the token and the client ID and secret that were used for my app registration. But then, with those, I can say, hey, AAD, give me actually a token to the graph on behalf of this user. And then I have permission to do anything that the user consented to earlier in their context. So if I update a SharePoint file using this flow, it'll actually show up in SharePoint as edited by this user, right? But of course, they consented to all that before. Those client ID and secret values are actually passed in as environment variables, right? So all the information about the incoming user comes in as headers. All the things that are properties of our application are environment variables. Does that make sense? So I promised that we would show some debugging. One of the biggest things that I see is confusion with audiences and things like that. And typically that happens when you're doing API-style applications, not so much if you're showing like content of the web app. So what we're actually going to do here is I'm going to use Postman, which is just an API client. We're going to go ahead and take that token that I saw earlier, and we're going to pass it in the authorization header as a bearer token. So this is just a way that AAD tends to have tokens passed in, and our platform handles as well. It's a general spec. I do need to actually grab the URL of the site really quickly. And what we should see is the HTML that we were serving earlier come back in our client. OK, so that's coming back. So we're good there. So now we want to break it. So first, let's just remove that token. So now we're just making a request. OK, we get a 401. That means they're not allowed to access it, right? And so they need to log in somehow. But what if I send the wrong token? So let me actually show you a quick trick. This is actually really good if you're ever developing against the Azure Resource Manager, is just steal a token from the portal. So what we're going to do is open our friendly F12 developer tools, and then I'm just going to navigate somewhere that's going to cause an ARM call to be made. So let's say deployment options sounds good. So we'll go ahead and click deployment options, and what we should see is get SCM info here. And we see that we have the token that the portal is actually sending back to the Azure Resource Manager. So we'll just copy that. Now, this should not work, right? Because that was a token that was meant for the Resource Manager. It was not meant for our application. There's an important part of how we validate tokens and things like that, generally speaking. You want to check the audience. That's who it's for. The issuer. Did it actually come from my AAD tenant? The signature, which is basically how the key was, how it was signed, and the expiration. Is this token still valid? In this case, the audience is definitely going to be wrong, even though everything else is probably correct. So we'll go ahead and paste that in, and we should see, again, a 401. Right? So we have a good failure case here. The problem is, all we get is a 401, right? How do we know? What if I thought that token was good? How would I figure out what was going on? Right? So you could actually do things where you actually go and crack the token open, figure out how it works and all that. But you can actually also use a property of the authentication authorization feature, which is we log everything for you. And so we can actually go see what was going on. This is the first thing you should do if you start seeing an issue with authentication authorization, is just see what the logs are telling you. So to do that, we'll go actually into the diagnostic logs feature. And it actually slightly overlaps with this session, but there's a session all about supportability that is going on this afternoon. So we'll choose the file system logging verbose. And we'll go ahead and open the log stream. So then, if I send a few bad requests, we'll get some logs. So this log stream just shows things that are happening while the session is open. And so we've got a couple going in here, and we see that we received a request. OK, we got that, but then we ended up giving it a 401. And there were some things where we did some login pieces. But specifically, we see right away, audience validation failed. The audience is the Azure Resource Manager, but that's not what we expected, right? Most common issue that I see in terms of authentication for users is audience validation issues. So this is the first place to go check, and then you're going to want to go see, hey, when I was getting that token, did I pass in the right value? Things like that. So that's user authentication. I want to jump back really quickly and start talking about what happens when I want to actually have my app have an identity. And to do that, we'll talk about managed service identity. So managed service identity is a new preview feature in Azure. Again, it applies both to app service and functions. I will make the distinction, though, it is not available on app service on Linux yet. So it's only on the Windows offerings. We'll be going through a functions example. So the idea here is my application needs to go talk to a bunch of resources. And it turns out a lot of the Azure resources can understand AAD identities. The problem is, how do I make sure that my app actually has an identity and is able to provide it? If I want to go talk to Key Vault, this is great. I'm getting secrets out of my source control, right? We never want to be checking these in. We never want them to end up in our code. But then how do you talk to Key Vault? Do you need a secret to start with? And then that secret isn't managed. And that sounds bad. And that's what managed service identity solves, because the entire idea here is you don't see any credentials during this process. You just are able to start using the identity, getting a token automatically. And the way this works is Azure will go ahead and provision all the credentials for you. We will get them associated with your application and make them available to it. But you only interface with it through a token service that we expose. It's just a local endpoint. And when you call that endpoint, we go ahead and take care of all the interesting AAD bits, and then give you that token so you can go call the designated resource. So that's MSI in a nutshell. We'll walk through two different flows. One will be, how do I actually go about doing that in a the raw requests, and I'll show you how to use some of the nice SDKs that Key Vault and a couple other have provided. So we'll start by going to our function app. Simple function app. For those who aren't familiar, what we're going to be doing is going into platform features, and that's the exact same as that left-hand navigation we saw in app service. I choose managed service identity, and again, we're just going to take a few clicks here. I'm just going to say that I want it, and hit save. right? And so this is us registering the client, right? Our application now has an identity. But again, we want to go talk to Key Vault. Key Vault doesn't yet trust that. We need to go make sure that it knows that it's OK for this app to get secrets. So to do that, we're actually wait for this to save real quick. So again, going through all the motions of getting those AAD credentials, putting them in the right place, and so on. Actually, it shouldn't matter if we exit the blade because the action will have completed anyway. We'll go over to our friendly Key Vault now. And one thing you'll note is that, so I've actually already provisioned this with a secret, but if I go look at secrets, I get an error. And the reason I get that error is because I haven't given myself permission to actually see these secrets. And this is a nice property of Key Vault. You can set it up so that your automation generates all the secrets, but no human ever actually has to interact with them unless they're like debugging your application, like with breakpoint debugging. So in order to actually let somebody read those secrets, I need to set an access policy, right? So now we're getting the resource ready to understand our client. And so if I go create a new access policy, I'll go ahead and select the principal. That's going to be the application that I created. So we'll go look up for the application name, and we will see two entries. One is the actual Linux application we set earlier, but two is a managed service identity, and this is the function app that we just registered. So I'll go ahead and select that and give it permission to get secret. OK? This is another place where I see the portal failing people. You still need to click save after you've hit that OK button, right? Otherwise, Key Vault won't understand what's going on, and it will just reject your request. Most common issue with a lot of these integrations is making sure you have the access policies on the resource set up properly. So that'll be good to go now. So let's jump over to our function again. And we'll wait for the portal to load here. I'm going to show you really quickly the the way that all those calls get put together. At the end of the day, it comes down to getting a token. Sorry, I know folks can't see that in the back. Getting a token, then getting a secret, and returning that secret. Right? So getting a token is the MSI part. Getting a secret is the Key Vault part. And so the Key Vault part's pretty straightforward, actually. All we're going to do is make an API call to a Key Vault URL. That's something I set up with an environment variable. Keep your Key Vaults separate with your environments, right? For a development environment, you have a development Key Vault. For production, you have a production Key Vault. Then we just give it the secret name and as part of the path, and then an API version that Key Vault knows, and then we parse out the result. But we have to attach a token as a bearer token, right? As we did earlier in a Postman. To get that token, we actually use two environment variables that MSI provides for us. We get an endpoint, that's where locally we should go to actually request that token, and then a secret, which is used as a header for server-side request forgery mitigation. It's just a security practice on our side. If you send that request specifying a resource, in this case, Key Vault, and API version, which is well known, then you'll get a token back. And at the end of the day, all this function does is it takes the input from the request and uses that as the name of the secret in Key Vault. So like I said, I already created a secret in Key Vault. Let's actually try this out and see if we can fetch that secret. Now, this is a scary key name because I know some of you are very concerned about Infinity War spoilers, and that happens to be the secret that we're going to share right now. Don't worry, I'm not actually ruining the movie for you. In fact, all I'm telling you is, if it works, and we see the output here, we got an exception. Hey, folks, we get to debug right now. So what could have gone wrong here? We see one or more errors occurred. All right. Status code not indicating success. Not found. That actually points to a functions issue, probably, unless I've named the secret wrong, which is very possible. In fact, there we go. So it couldn't find the secret because I spelled it wrong. So we'll try that real quick again. And we get my opinion that it's a good movie. So we were able to pull a secret from Key Vault, and at no point did we ever see any secrets ourselves. We didn't actually have to, we don't have to rotate anything. Azure takes care of keeping everything rotated and up to date. There are no certificates to manage. This is very, very powerful. Now, that was a little bit more code than we generally like to see, right? So very quickly, I'll just show you that there are a couple of SDKs that are very important. There's a Key Vault client. There's a Key Vault client, which actually makes it much easier to actually pull secrets out. And it integrates very well with another library called the Azure Service Token Provider. What's nice about that is it actually is an abstraction. It uses MSI when in the cloud, but if you're developing locally, it will fall back to using your identity that's logged into Visual Studio or the Azure CLI, or Windows integrated authentication. So what that means is when you're doing development, again, we want separate key vaults. But my development key vault, I can have access to it, right? Because I'm the developer working against it, against my instance. And so that makes it much, much easier. So I strongly recommend if you're using .NET, the Azure Service Token Provider, that library is a must-have. So we're running short on time here. I'm about to run over a little bit. So really quickly, let's just see what have we done here. So we learned about authentication, just in general, how we can use the app service authentication authorization feature to log in users easily, and how we can start leveraging that user identity, right? We have those headers available to us, and we can do things on behalf of the user if they want to go talk to something like Graph. If something goes wrong, diagnostic logs are probably our best friend there. For managed service identity, we got rid of some secrets. And what's nice is we don't have to use Key Vault, right? That's just one example. Things like SQL actually know how to deal with Azure AD directly. Same with event hubs, and a bunch of other resources in Azure. And so you'll see that over time. So you can actually get rid of secrets entirely. And then, of course, use those libraries that I mentioned. That's a huge savings. And when you're dealing with debugging, right, both client and resource, what we saw actually when my demo broke was the fact that, hey, OK, there was an error, and that was coming back. But it was actually coming from Key Vault, right, because I spelled the key name wrong. So you always want to check both ends. And, of course, definitely make sure those access policies are good. So there's, we of course want plenty of evaluations. Please let me know if this is valuable. Also, feel free to catch me afterwards. I'm going to be heading over to the Azure Functions booth immediately after this, so I'm glad to take questions there. And there's lots of other great sessions in the serverless, app service, and identity spaces that you should definitely check out. So thanks very much for your time, and I really appreciate it, folks. Thanks.